In this video, I'll be sharing how to create this design, which is a courtyard building that is a single standalone building that is fully parametric. I'll be going over a lot of techniques that are useful for many other designs. We'll be creating this design that has walls, it has openings, it has roof overhang, and a few details that are useful for buildings like this. There's not going to be a lot of detail going into this. This is a base form. But from this, we can take that building and develop it using some Rhino modeling and save ourselves some time in designing and kind of coming up with the best design. So what we'll do here is let me share with you some of the parameters. The building form. This is the depth of that building. And like I said, the concept is going to be to create a building that will shelter you from all sides from the sun, and you can even do some planting on the inside. I'll share with you here, let's see some of the things here. The depth of the foundation. We have the overhang. Here we have that form. And one of the most important things, of course, is going to be the door opening. And we have it here so where it creates an opening through both the front and the inside, but we also have that ability to make it so it's not necessarily all the way in. Let me show you how. We can make it so it's only that window on the inside. So the first thing we'll do is bring in a point. So I'll go here to construct point. Then we'll move this point here over to the right. So we'll take this point, and I like to route it through another point component so we can change the location. Now we can use this one and now move it. So I'll go here to a move component. We'll plug the point into the geometry input. Now we can move it in a specific direction. And here I like to go in the X direction. So double click, go to unit X, and bring in a slider for the size of the length of the arc. So let's go here to 15. So now with these 2 points, now we're going to bring in the arc component, which the one that I would like to use is arc 3 points. And the reason for that is because it actually gives you some control as to how far apart these points are going to be. And then there's going to be like this amplitude that's going to be going into this direction. So what I'll do is I'll take this point and create a line in between the two. So I'll go to a line component between the start point being the first start point, and then that geometry that I moved in the X direction, that's going to be the endpoint for the line. With this line segment, we now want to get the midpoint. So I'll go here to a curve middle. This will give me the exact midpoint of that line. And now we can take that line or that midpoint and move it in either the Y positive or Y negative. Let's go here to move this point. I'll put that midpoint into the geometry, and then the motion is going to be unit Y and negative. This way it moves it in this direction. Now I'll bring in the slider, so I'll go here to 15. Now I can move the slider around and have kind of the amplitude of the arc. So with those 3 points, I'll hide this midpoint, and I'll take this point that we moved up, that's going to be point B. That's going to be the middle point. Then we're going to plug in the first point into point A, and then in point C, we're going to be doing this one, the one that we moved initially in the X direction. So we'll go here to point C. And with this, we have the ability to create kind of the length of the building. We're going to have the arc amplitude. And that's going to be the base geometry for this building. So with this, now we can take this arc and we can offset it for the depth of the building. So we'll take this arc, we're going to bring in the offset component, offset curve. We'll plug in the arc into the curve input, and now we'll give it a distance. We'll go here to 15. And the reason why I do 15 is because I want to do more than 10. That way we have more than from 0 to 100. And this way I can just move it around at that level. So we'll go here to this one and we can move this around, and we see that we have offset it by whatever slider we have here. Now what we need to do is create the line segments that are going to close this down. So to do that, we already have the points here, but it's okay to bring in this component called endpoints, which what it'll do is it'll give us the endpoint for this arc. I'll create a copy of that component so we can create the start and end points of that other arc here that we offset. Now we can connect it using a line component. And we are now going to create two line segments between the start and start point, and then the end and the end point. So we'll go to start and start point going into that end point, and we'll do the same thing here. So we basically closed it down, and we can see that line segment a little bit better this way. The cool thing about this building form is going to be that it's going to create a courtyard on the inside, and that's the concept for this. This would be a structure that would actually be in the desert or something like that, where it would cover from sun most of the day, and you can actually either gather in here or plant on the inside. So with this, now we have those two segments, and this, now we can actually create the walls. But what we need to do first is join that together. So I'll go here to a join curves. We'll join the first arc, the offset arc. So hold down shift to add another curve, and then I'll hold down shift to add those other two. Then I'll go to the input, flatten it, and then here at the output it says one closed planar curve, and that's great because that's what we can use to create our floor plan. So what I'll do is I'll go back here and we'll make sure it's kind of a smaller building at first, because we can always make it really large, but we want to keep it tight. Let's go here to something 25. Okay, so now with this we're going to create the walls. What we need to do is go here to this curve. Now we're going to offset it. So I'll double click here, go to offset curve, and then I'll plug in this curve into the input, and automatically it's going to offset to the inside, which is good, but we want to give it a specific value. So we'll go here to 0.5. Now we can create the walls. So the way to do that, this technique is going to be to create a surface between these two, and as long as they're on the same plane, you can do this. So bring in boundary surfaces. We'll take the outside curve and the inside curve and plug them into the input. Then, as you can see here, they're going to overlap. So the way to fix that is right click on edges and then go to flatten. This will make sure that it creates a surface between those two curves. And now we can take this and extrude it for a wall height. So now we can take this, we'll go here to extrude the surfaces. In the direction, we'll go here up in the Z direction, so it goes up. And we'll bring in a slider to do the height of that extrusion. So we'll go here to 12. Now we can disable the preview on all of this stuff. And see that we have basically the wall height taken care of. For this next part, we need to create the opening. Now the opening is going to be located here in the middle. So we can either use this midpoint or we can pick a point along that initial curve. Either way, when you extract that point, like this one, this midpoint, that was moved in, now we can use that to create the line that's going to be extruded to create that opening. So I'll go here to move, and we're going to move this point in the X direction. We'll go here X or unit X, and then we'll plug in a value, let's say 4.5. in the X direction. Now what happens is, since we're doing it from the midpoint to one side and then to the other side, we actually need to divide this by 2. So we'll take 10 divided by 2. And when you do division by 2, it's going to give you a component that has 2 at the bottom as B. So we can plug in the 10 into the A and then the result into the vector. Now we can do the same thing in the opposite direction. So I'll go here to negative. I'll plug in the vector into the negative input. Now the result, I'll hold down shift and add it into the motion. So now we have 2 points that have been moved from the center by half of the overall length, which gives us the true length between these 2 points. With that, we can take those 2 points and create a polyline between those two. So I'll take that geometry, which are going to be the points that are moved, into the vertices. And if 10 is too small, which it is, let's go here to another value and we'll increase the maximum to 50. And now we can take this and extrude it up to be the height of the door or of the opening. So we'll take this polyline, we'll go here to extrude. Direction is going to be in the unit Z. And the height is going to be, we'll bring in a slider, 8.5. Now with the surface, we can take this and extrude it in either Y or, yeah, we have to do it in the Y direction. So one trick is going to be to move this in this direction and in this direction, or move this surface in this direction and then extrude it in the opposite. So let me show you that trick. And that's to make sure that it intersects the form completely. So we'll take this and we'll first move it in the positive Y direction. So we'll plug this in, we'll bring in the unit Y, and we'll bring in a negative component because we know we want to move it in the, oh, it's a positive Y. We'll have the negative here because we need that, but we'll take this and move it in let's say 15 this way. Then I'll take this and disable the preview. And I'll take this and extrude it in the negative Y. So I'll take this, bring in an extrude component. We'll plug in this surface into the extrude base input. Now the direction is going to be negative Y. So I'll copy this slider down here. So I'll slide it, tap Alt to make a copy, then bring in a negative value so I can extrude it in the opposite direction. Now if I do the same amount, well, it's going to shift it by the same amount. So we can kind of do something like this and then extrude it further this way. If we want it to, let's say, open all the way through to the other side. Now we could have a different size opening for this side, and we can do that by going back to the original curve, maybe taking this, getting the midpoint of this one, and then doing that same process that we just did. But for now, we'll keep it simple. We'll have this extrusion that intersects this, and we'll subtract it. What this will do is create the opening for the courtyard and possibly kind of the front entry. Now this is going to be a basic form, so don't expect to see a lot of detail. Some of those things can be taken care of inside of the modeling. So for now, what we'll do is we'll take this form and we're going to go to a difference, solid difference. And we're going to take the walls into BREP A, and then this box into BREP B. Now it's going to subtract it. So now I can take that form that we have here and disable the preview. And I'll do the same thing with the box down here. We still have base surface previewed. So I'll disable the preview either by right clicking and clicking on preview, or select multiple and then do middle click and disable preview. Now, I do like to show, if you don't see the things the way that I see them, it's because you don't have display and all of these enabled, and I like to have that so you can see, read the icon, so you can see the icon, read the inputs, and it makes it a little bit easier. So with that being said, let's move some of these parameters around and let's take a look at the building and what it does. So this is going to be these 2 points in between. That's going to be that arc, the opening. And we can kind of see that opening through the size of this. And there's going to be an offset. That's going to be that offset. And then here, the height. This is going to be the overall length and the width. So we have a lot of parameters, and that's kind of the form that we're trying to go for. The next thing we're going to do is, not only do we want to subtract it, but we also want the form where the window is taken away. So if we want to bring that back, we can do an intersection or solid intersection between the walls and that solid. So we'll plug in that extrusion into BREPS B and then disable the preview here. And so now we have where they intersect, which is going to be the same place as where the openings are taken. And I see a bit of an issue here. So I'm going to change some of these sliders here. what I'm doing is I want to take this and make it a little bit wider. Go here. So it kind of creates a clean opening here. And I actually don't want it to offset that far in. We have this one at 10 and this one like so. Okay. So sometimes we can use some of the components that we don't necessarily want to preview, but we can use them as guides to see how our model is intersecting. And the reason for that is a lot of the times you don't want to preview everything. This way you can kind of focus on the things that you're changing, and most of the stuff that you're changing is going to be kind of on the right hand side, the outputs. So just keep that in mind, that some of these you may not want to have on later on, but you might want to keep on to reference. So with that being said, we're now going to move on to creating the roof overhang. Then we're going to create a small detail to connect between the two. On this next part, what we need to do is take that bottom outside line, bring it up, and then offset it to the outside to create a roof overhang. So we'll go back here to where we joined this base form curve. What I'll do is I'll give myself a little bit of room. So I'll take this and move this down. Then I can take this and move it up. So I'll go to move this curve in the Z direction. So I'll go to unit Z. But I may not even need to do that because I already have the height extrusion of the wall. So if this is the height of the wall, or no, that's the height of the window. If this is the height of the wall, then I can use that Z vector that I had already created for that wall as the vector for our motion. Now we can take this, now that we moved that line up here, and we can offset it to create the overhang. So I'll bring this down here, and I'll go to offset curve, and I'll bring that geometry into the curve input. And the distance, well, as you can see, it's offsetting to the inside. So I'll bring in a negative component. This way it offsets to the outside, and I can now use a value of, let's say, 2.5 to create that overhang. Now with this, I can create a boundary surfaces and extrude this up to create the thickness of the roof. So I'll go here to extrude. We'll bring in that surface into the base input, and the direction is going to be unit Z for it going up. And I'll go here to 1.50. Now we've basically taken care of the roof form. Now it looks super basic. So what happens is typically you're going to have the roof rafters, and then you're going to have a fascia out here. And so we can do that because we have this curve that creates this form. So what we can do is take that offset and offset it again. So I'll copy this, tap Alt, and plug in that curve again into the input. So it's offsetting by 2. So we'll just say here to 0.2. And now I'll create a surface between these two. Using that same technique, we'll use boundary surfaces. And we'll plug in the outside one, the inside one, we'll flatten the input so we know it's just creating that surface here. And what's going to be different about this, and it's a good trick or a good technique, is to, since I know how much I'm extruding the roof by, and the fascia, I want it to go past the bottom, I actually have to take this surface, move it up, and then extrude it down by more than the thickness of the roof. So with all of that being said, let me show you what I mean. We're going to take this surface, we're going to move it up by the same amount as this extrusion, right? This surface into the geometry and the extrusion into, or that same vector into the motion. Well, now we can kind of forget about it down here and even disable the preview on this. And now we can extrude this down, and if we use the same amount, well, it's going to just extrude down the same amount. But if we do more, we can actually pick the overhang amount. So that's, I feel like that's super useful one to kind of know. So we'll go here to extrude. We'll use this geometry into the base input. Then the direction is going to be negative. And it's going to be this value plus, so we're going to add the overhang amount. If that's what you want, we can actually pick a specific value that's more than, more than this. But if you want an overhang value, this is how you would do it. 1.36 plus the overhang amount. So I'll do 0.25. Then that's going to be down in the z direction. So we can actually do the z vector here, then negative. And then the result is going to be the direction. So now we can have this be the overhang amount, and it's tied to the height of, to match the height of the roof. If we go to a foot roof rafter, then there's going to be 0.5, 6 inches overhang here. The cool thing about this, in my opinion, is that we have a different material here. We have a roof rafter here, and technically, if we move the curve up here and we extrude up, that would be the roofing material. So let's do that. Let's make sure to kind of do this clean. And remember that we created this boundary surface down here that we moved up. Well, we don't need to move that up. We need to copy the fact that that was moved up and move something else up. We're going to move the outside line up. So I'll take that curve, I'll plug it into the input, and now here we have the outside curve. Well, now we can turn that into a surface, boundary surface, and now I can extrude that up for the roofing material. So I'll go to extrude, in unit Z, and I'll do 0.250. So we have roofing material, we have fascia or outer trim, we have roof rafters, and here we have outer walls, we have our window, and that concludes the basic form of the building. Now I am going to create here another basic trim form, and I'm going to show some tricks to kind of get that done. Other than that, those are kind of the techniques and the tricks that I wanted to share for the most part. So I'll disable the preview on everything except for our brep outputs. This way I don't have things overlapping and it's a lot easier to visualize things. And one of the things I want to share too is you can always change the form of the building. So this is fully parametric, and we can change the location of where we want this design. The idea is that we're going to align this east and west, and then the sun is going to go around here, and we're going to have the ability to plant and gather on the inside, whether this is a really hot climate or, you know, you just want some privacy. So with this, let's go to the next part, which is going to be the form between the wall and the roof. So what we'll do is we'll take all of this portion of the design that kind of takes care of the roof, and we'll middle click and disable preview, and we'll go back to the place where we had this initial line. Now this line here, we did move it up to create the overhang. So we go back here to this one. And now what I want to do is create the overhang design, or the trim between the overhang and the wall. So we'll take this and we'll go to offset curve. We'll plug that into the input, and it's offsetting to the inside. So I'll bring in a negative value and offset it to the outside. I'll say 1.5. Got to be a little bit smaller than that. Okay. Now the next thing we're going to do, which is a little bit counterintuitive, is take this and offset it back to the inside. This way, we can then move it down and create a slope form. So with that, we'll take this and we'll offset again. We'll copy the offset, plug the offset into the input, and then use a different slider that offsets it to the inside. Now, I wouldn't do it exactly the same amount. I would do it a little bit to the inside, and you'll see exactly why. For this, for this next step, we'll take this and we'll move it down. So we'll go to move. We'll take this curve, plug it into the geometry input, and then the motion is going to be negative because we want it to go down, and then Z in the downward vector. Then I'll create a offset slider. Now we can move this up and down. Well, the reason why we did this is to create a slope line between these two. Now we can take a loft component and we can loft this top one and this one that we brought in and down. So we'll take that and this one, holding down shift, we'll add the other input, and when we flatten the input, it will create a slope or a diagonal between those two offsets. So this is why we offset it to the outside to create an overhang, and we offset it back to the inside to make sure that we have a slope. But the reason why we want to keep a little bit more than the wall is because we're going to subtract it from a form. So to do that, we're going to take this, we're going to plug it into a cap holes component, which will make sure that this is actually a solid. It will actually give us a solid between those two slopes. It'll give it a cap at the top and a cap at the bottom. What we can do now is use that solid and subtract it from a form that we have with the polyline that we created at the beginning. So some of these designs do get a little bit complicated, and I want to be able to explain everything completely. So if you do have any questions, if I went over something too quickly, please let me know in the comments. I want to make sure to have everything clearly explained for you guys. So now that we've created that solid, we're going to take that initial line, this one, we're going to extrude it by the height of the wall. This way we create a solid from that extrusion. And this goes into creating things that you're not going to see in the final design, but it'll help you in completing your design. So I'll use this bottom one and I'll plug that into a boundary surfaces to create a surface. And I will extrude this up by the same height of the wall. So this is going to be the height of the wall, 12. And I'll take this and I will extrude it up by the same amount. Now I can either bring in an extrude component and plug them in, or I could have just copied this one. So either way, we want to use the same vector that we used for that one for this one. Now, as you can see, it actually turns it into a solid. So I want to disable preview because I don't want to preview that, but I do want to use that as the solid that I subtract from this. So I'll go here to solid difference, and I'll go to solid difference between BREPS A, which is this, and BREPS B, which is going to be the solid that I just extruded. What it'll do is give me what you see in green, which is the result of that, and I can disable the preview on everything else. Including that form. Now I've created this really neat trim that creates kind of that clean connection between the wall and the roof. So now let's go back to this roof section, enable the preview, and enable the preview here. And so now that looks a lot cleaner. And it kind of takes care of that connection there. All we would need to do here is apply materials, and inside Rhino modeling, just getting some of the details for the windows and stuff like that. And that's what I'll be doing for the final kind of result that I'll be showing in the thumbnail stuff, is some more modeling that I do that I'm not going to be filming, but this will just go over the overall form. So the last thing that we'll do is create the base form or the base foundation. Now, what I'll do is I'll just take that overall form and I'll be extruding it down to create the floor slab. And we've basically taken care of that back here, where we created the boundary surface that we extruded up to subtract from this form. Well, we'll take this and we'll extrude this down. So we'll take this boundary surface, go to extrude, plug that into the base input, and then go to negative Z, and we'll just bring in a slider. We'll just say 1.5. So that concludes the tutorial. Like I mentioned earlier, if you have any questions, please make sure to let me know. I would love to know where you got stuck, if I got something wrong, or if you have future ideas for videos, please let me know. I'd love to know some feedback. And thank you very much for watching. So what I've done here at the end is just cleaned up the outputs, brought them all out here, and then done the same thing with the inputs, just kind of cleaned them up, labeled them, and then I grouped them together so I can see which are the inputs that are kind of the most important ones. There are some that are not as relevant that I don't necessarily highlight, but yeah, if you have any questions, I'll have both of these under the Script Vault portion of my website. and consider becoming a member. That really helps me out, and I'm pretty sure you guys will learn a lot from a lot of the things that I have here. So thank you very much for being here. I hope you enjoyed this content. Let me know if you have any questions, and I hope to see you next time. If you enjoyed the content, make sure to give it a like and subscribe for future videos. I make videos like this every week where I share the process for creating architectural and parametric designs using Grasshopper for Rhino. And if you want to get a hold of the script that I made for this video, check out my website capettidavid.com. There, when you become a Script Vault member, you'll have access to the video script and much more. I also have a script store with scripts that are ready to go, and you can also contact me there. And if you're brand new and have never used Grasshopper before, I would suggest checking out the self-paced workshop that I have on my website. Thank you very much for being here, and I hope to see you next time.